Hey, so for the summer I'm going to try this mostly weekly series where I produce videos showing my progress on my game, or if I lose motivation for it, whatever other project or projects I switch to. The primary intention of these is to keep me motivated. I think it'll help to be able to look back at what I got done. A happy side effect is that the videos become content for you. Now, once my job starts, we'll see if I have time to really make enough progress to warrant continuing to make these videos, but that's a bridge I'll cross when I come to it. For now, I'll get into what I did this last week. So, I've been starting to prepare my game, which for now I'm calling Sporgler Tiles, for playtesting. As a brief intro to Sporgler Tiles, it's a roguelike deck builder, or more accurately, board builder. You have a board of tiles that represent attacks, and on each turn you can move orthogonally to use those attacks. You can't cross your path until you hit a refresh tile. As the game progresses, you gain more tiles which you can install onto your board. Once a tile is on your board, you can replace it with another tile, but you can't get it back into your inventory. I'm making the game in libgdx, mostly just to learn a new game engine, though this one's closer to a graphics library. This week, I added a lot of UI. I made a whole button system as well as a pop-up menu system. This allowed me to finally add an end turn button rather than making the player press E every time, and it allowed me to add the pause menu, the loot screen, the game over menu, and the game winning menu. 4 very important and long overdue additions that make the game fully playable start to finish. I made the names of the fighters display too, but that was a quick fix. In getting excited for playtesting, I wanted to try something I hadn't done in a game before: statistics. I'm hoping I'll get my friends and classmates to try out this game, and it'd probably be pretty useful to see how they're playing the game without having to manually watch them. The balance of a game like this seems important, and what better way to get it right than through numerical analysis? So I began to set up a database that keeps track of various events and stats throughout the game. I kept track of stats for players, things like individual runs, win rates, times they quit or restart runs, etc. Stats for specific encounters, how often players win against them, how often they cause players to quit, things like that. And most importantly, stats for specific tiles, how often they're used, how often they're replaced, how often they're bought in the shop, how often they're equipped, how much damage they do, etc. I also keep track of what happens in a given run. Things like starting fights, taking turns, the specific tiles used, and the amount of damage done. This would allow me to make a decently detailed reconstruction of what happened in a given run. So if I'm confused about a specific move someone made, I should be able to see the surrounding context. But more importantly, it means keeping track of individual fights. When someone loses or wins a fight, I can hopefully run some stats to associate what tiles players have with how well they do in specific encounters. To set this up, I use an SQLite database connected via an API I programmed in Node.js. The first version of the database and API should be done, but there's still a ways to go before this is functional in the game. First, the database needs to know what specific tiles and encounters exist, and it needs to agree with the game about which one has which ID. I originally planned to make all the tiles via JSON. I might still do that in the future, but I abandoned that plan because the system quickly became more complex than just writing them in Java. Luckily, the Reflections library will let me iterate through each Java class that extends the abstract tile class and do the same thing for encounters. I've set up the library, and my next step will be to write the code that assigns each of these classes a unique number and stores it in both the database and a JSON file. Then at runtime, both the tile and encounter class will find their associated entry in the JSON file so that it will agree with the database. This way, each time I update the game, I just need to rerun the database setup file once. The other upcoming database step is to actually send events from the client to the API. For this, I'll use libgdx's built-in JSON library and a web request library of some sort to send the requests and get the relevant responses. I'm hoping this step should be fairly straightforward. Once I have the client code working, I might also make some quick data visualization tools so that I can see graphical representations of the data I've gathered rather than just raw numbers. But that's a task for another day. For now, there are more pressing matters before I get the first playtest version out to my friends, like adding tutorial text to the game so they know what they're doing, and adding a few more synergies and gameplay styles to make playing a bit more interesting. But that's about it for this week. Hopefully I'll be able to put out a video around the same time next week. Goodbye.